For setting up a 7, 8 or 9 series Avalon miners that on their control board they have only an FPGA and not a microprocessor to install an operating system to provide a web interface and investigate the miner status, we have to make use of a separate controller. But we need to configure this controller first before we could use it. This information may look ordinary for most users, but I myself had lots of problems configuring my Raspberry Pi controller, and there were no resources or YouTube videos to explain this easy tutorial. So I decided to make this video, and I hope that it could help you in configuring your controller too. The first step is that we have to select the right model for controller. The controller I'm going to explain here is Raspberry Pi 3. If you have a Google search for Raspberry Pi, you will see there are different types of Raspberry Pi controllers, but there's only firmwares for Raspberry Pi 1, 2, and 3 on Canon's website. We also have another controller which is in black case, and its CPU is from Avalon Technology, which are called WIFI, H2 or H3. We are going to go with Raspberry Pi 3, which has two different models. Model B and Model B+, the company is not providing the firmware for Model B+, so we have to choose Model B. For this video, we need the Raspberry Pi 3 Model B. It's 5 volts AC adapter with Type B USB connection, micro USB connection, LAN cable, micro SD memory card, the AUC adapter and its cable, which I'll explain later. For the first step, we need to download the firmware from Canon's website. The website might be upgraded and look different, but it's always in the service and support section. Here is the list of devices which need this controller to work with, and their firmwares are available. For example, I choose model 921. There are some subdirectories in this branch. We will need OpenWRT and section for our work. OpenWRT is the firmware that we want to install it on the Raspberry Pi 3 Model B, and later we need to change the version of board using this file. Here, stands for memory map file, and if it doesn't match with the version of the controller firmware, you will have problems getting the best hash rate of your miner. When the version of board and the firmware of controller doesn't match, you may see weird things happen, like the light of the miner goes blue but the hash rate is 0. So we need to choose the firmware version which is close to the version of the device, or we have to upgrade the afterwards to make them match. Well, as an experience, I think that 190301 is working more stable than the other versions, and according to that, I will choose the 190304 version. Here I choose Raspberry Pi 3 Model B, and I have to download the image file, which is about 76 megabytes, and we need to download the MCS file for version. If you want to program it by a programmer, you may need the bit file format too, but for upgrading the file through the web interface of Raspberry Pi, you just need the MCS file. I've already downloaded them. Our next step is to put the memory card in the memory card reader of the laptop. Using SD formatter program, I'll format the SD card. You have to pay attention that it's better that the memory card's capacity shouldn't be less than 4 gigabytes and more than 16 gigabytes. It should be between 4 and 16 gigabytes. After formatting the SD card, I'll choose the image file which I've downloaded earlier here in the Win32 Disk Imager program, and I'll click on the right button. When done, I'll pull out the memory card and put it on my Raspberry Pi. After I put the memory card on the Raspberry Pi, by default, it should be connected by LAN cable to the laptop, and the default IP which it will take is 192.168.0.100, and you have to pay attention that if you want to connect these two devices to each other, the IP ranges should be identical. And because the IP range of laptops is not 0 by default, you may face problem in first connection. So we have to configure our laptop IP range to be same as our Raspberry Pi. We go to network connection section and we go to property window, and then we double click on IPv4. Here we don't want our IP to be assigned automatically. We want to change it to 192.168.0. Let's say 105, and the default gateway should be 192.168.0.100. Now I expect that I type the Raspberry Pi IP address in my address bar. I could see the web interface of that, and here it comes. So you saw that I could connect to Raspberry Pi, and default password for this page is root as any other miners. I click here on advanced version. We see lots of properties here that's explained in another video, and I'm just explaining a little bit of those. Well, here CG Miner configuration page shows our pools information, and we have to set the pool's address and our workers information here. CG Miner status page shows the connection stats of the device, and the temperature information and the hash rate of the device will be listed here. CG Miner API log section is the most useful part that will help us in troubleshooting. After connecting to the miner, a list of detailed information about the device will be shown here. On the upgrade section, you can change the memory map file of the board to match it with the controller's firmware. One of the interesting options of the Raspberry Pi 3 is that it's able to be connected to router or hotspot of the mobile cell phone through a Wi-Fi connection, and you could get rid of the wired connections. We go to the network section and we click on the Wi-Fi, then we scan the existing Wi-Fi networks. This is my cell phone, Samsung Galaxy A8 Plus, and I'll enter the password of my Wi-Fi. Then I save it and apply. Now Raspberry Pi 3 is connected to my cell phone. Now the Raspberry Pi 3 is connected to my cell phone. To make sure, I separate the LAN connection, and scan for Raspberry Pi IP using my phone. You can use any IP Finder app or network scanning applications. Well, you see 43.233 is the IP that the Raspberry Pi is connected to my phone through. Let's connect to the controller to the device, and I will explain the further features after that. Well, after preparing the controller, we connect to the device. When we hit the power button, a white light turns on the device, which shows that the miner is being initialized. Well, as you see here, well, there's a problem with my device's status LED, so it's not shown, but I'm pretty sure that you can see that in your device. After this step, the fan speed drops down and the light goes to greenish yellow and it starts to wait for the controller to connect to the pulse. If everything goes fine, the AUC converter will flash several times and change from blue to green, and the light on the device turns blue, which means all the connections are okay. Sometimes for this initialization signal, you have to pull out the USB connector and plug it again. As you see, when everything is okay, the green light on the AUC converter stands green and doesn't change or blink, but in any case of errors or noises in the system, it will change after a few minutes or start to blink red. Now, by connecting to the web interface of the Raspberry Pi, we could investigate the detailed parameters of the device. We enter the user interface of the Raspberry Pi. The username and password is root by default. In CG Miner status, we see the pool information, which shows that the connection to the internet is okay. Every time I click on CG Miner status, it refreshes. In this section, the Avalon devices, it shows that the old devices, which devices is connected to the AUC. When the AUC light turns green and the light on device turns blue, a few seconds later, this section shows the connected device information, like the device name, version, DNA, hash rate, temperature, fan speed, and PMU board status. After connecting to the device, as we see here, it's showing that the device is A921S and the version is 1901 and the DNA is 09C0. If you notice the temperature and the gigahash per second value, it's rising every time I refresh the web interface, which is a sign that the device is working fine. Avalon A921 is 20.5 terahashes. But as you see, it's not going further than 10 terahashes, so it means that there might be a problem with the device. I click on the CG Miner API log and push debug switch button to show every detailed properties of the miner. I'm giving out a brief explanation of some of these parameters. This is the complete DNA number, which the last 4 digits are shown in the miner status page. This is the unique board ID of every device. To write this number on the device with a marker for later troubleshooting. The next parameter is elapsed time, which shows the time of the device on times, which is in seconds. Next parameter is mberg, which shows the work of each hashboard, and here we see that the work parameters of hashboards number 2 and 3 is 0. Here we see the temperature of device, temperature of hottest chip, fan speed. VI and VAO are input and output voltage, which we see are correct for all channels, but we see that the gigahash is in half. Looking at ECHU shows that hashboard number 2 and 3 are working faulty, and they are not detected by board, and the information of the temperature and voltages are not shown here. Needless to say that the hashboard counting starts from 0. Here we have to disassemble the device and take out the faulty hashboards. and start troubleshooting using an oscilloscope. Using an oscilloscope, we will track the signal to see where it's disconnected. This was a brief explanation of CG Miner status and CG Miner API log pages. If there is any problem or question about any of these information, you can contact us using our WhatsApp line. Thank you very much for your precious time, and I hope this video was helpful. Thank you.